Welcome. My name is Nathan de Ruiter. I'm a partner and managing director at Novaspace, which is a consulting and market intelligence firm dedicated to the satellite sector. So thank you for joining us today for this new webinar, GSOA webinar series. Today's webinar is supported by ST Engineering iDirect, a global leader in SATCOM, providing innovative, high-performance solutions for broadband connectivity. With a reputation for delivering reliable and scalable technology, they empower businesses and organizations worldwide to stay connected no matter where they are. So today's topic of the webinar is empowering autonomous satellite networks, AI, ML, and the cloud revolution. Well, let me first introduce to you the panelists of today. We have a great lineup of people with first-hand experience on the topic. So first, Mr. Sridhar Kuppana, who is the CTO and Senior Vice President of Engineering at STS Engineering iDirect. We also have Ming Nungjeng, who is the Architect Emerging Technologies team at Microsoft Azure. We also have Will Mudge, the Executive Vice President and CTO of Speedcast. And last but not least, Ken Takagi, Director of Business Development at Intelsat. So I will start a little bit with the context, and then we'll directly go into the Q&A and also have the opportunity to hear more from our speakers. But from the context perspective, I believe, traditionally the satellite communication industry has been somewhat cautious and often slow to adopt emerging technologies when compared to what we've seen happening in the telecom or cloud. But I do believe that dynamic is shifting and quite fast. So AI and machine learning are no longer the buzzwords. They're already transforming industries across the board, and SATCOM and satellite industry is now at a critical inflection point. So the question is not whether we should adopt these technologies, but it's how we lead with them. So today's session is really about exploring that leadership path. So together we'll dig into the practical applications of AI, machine learning, and cloud-native systems in our space. What are the most valuable use cases? What needs to change in our infrastructure, in our thinking, in our collaboration models? And what does the holy grail of intelligent, autonomous satellite networks really look like? So before we start, I would like to remind everybody, do you have a chance to ask your questions throughout the Q&A function? So please don't use the chat, but the Q&A function is the right method to share your questions with our speakers. So we'll make for sure time to address those questions, probably more towards the end of the webinar. And I think, what we can do now, I believe we can just go into the first question for my speakers. And maybe Sridhar, you're up first on my screen, so I asked you to go first, but I would like each one of you to kind of, introduce yourself, tell us a little bit what your company has been up to and how it's currently involved in applying AI, ML, or cloud-native technologies within the satellite industry. So, Sridhar, if you can go first, please.
Thank you, Nathan. I'm happy to be here and joining my team of experts here on this topic. I'm the CTO and SVP of Engineering at iDirect. We build ground infrastructure for satellite communications. At this point, we are working on next generation platform called Intuition to move the satellite communications towards virtualization, develop a multi-orbit solution, and leverage AI to solve the problems that the SATCOM industry faces today. The AI technology has come a long way. As you rightly pointed out, Nathan, it's no longer a buzzword. It's right now being used in telco very actively. And I'm pretty certain that we can leverage AI to solve some real world problems in the satellite industry as well. Ultimately, I think our goal is to leverage AI to help drive the SATCOM industry towards more autonomous networks and improve operational efficiency and bring cost back, save some cost, and provide other capabilities that AI is really good at, right?
Perfect, thank you. Ming, you want to go next?
Sure, thank you, Nathan. Thank you for having me and allowing me to participate on this panel with the esteemed panelists that I see here. So my name is Min Nguyen. I work for Microsoft, specifically in our emerging technologies team. We stood up the emerging technologies team a couple of years or 2 or 3 years ago in order to focus in on a few non-traditional, I'll say, Microsoft technologies, right? So back then, it was a lot of space. Azure Orbital was one of our primary focus areas. Then generative AI became a much bigger kind of a thing. And as Nathan, you and Sridhar both mentioned already, it's really come out of the realm of emerging anymore, right? And it is very much now a sort of mainstream kind of a thing. But what we do see as emerging is the application of specifically generative AI into operational kinds of systems, right? And the trust that's required for that. But anyway, so the ETT also deals in technologies such as quantum and secure mission infrastructure. My personal focus is on generative AI as applied to the space industry. My personal background is 22 years of building Earth observation systems, both sound, space and ground systems for different government agencies as well as commercial companies such as Boeing, Digital Globe, Maxar, and the Aerospace Corporation. In terms of Microsoft, right, it's a behemoth. But where we are focused on in the world of AI and ML is really enabling companies and organizations to build the next generation of AI infused applications and systems. And so to that end, we provide many services, and we'll get into much of those later on, but from cradle to grave in terms of from ideation to operation and sustainment of AI systems, as well as from the top to the bottom of what we call the AI sort of value chain, right? From large language model based multi-agent systems all the way down to bespoke specific ML models for doing object detection and anomaly detection and things like that, all the way down to data curation, data cleansing, right? And then all of that rides on obviously the Azure backbone cloud infrastructure that allows for distributing these systems in a reliable, performant, and secure kind of a way.
Great. Yeah, I will look forward to hear more about those examples in more detail later on in the discussion. But Will, maybe you can go next. So, intro.
Hey, thanks, Nathan, and thanks to the panel here and everyone attending. So my name is Will Mudge. I'm the CTO of Speedcast. Speedcast is a managed service provider, so a little unique here. We use Intelsat, we use ST Engineering, we use Azure as we provide our services. So got a lot of really great companies here that we work with on a daily basis to bring these AI and ML services to our end customer. It's a journey that we've been on for many years. I think, there's no secret that we've been selling Starlink for a long time. We've been using SD-WAN to bring these things together, building our databases and helping build our code to be able to enable this AI journey. And it's really a great step in this whole journey and this discussion. So very well timed on how we're able to take the growth through the industry and the progression of it and to deliver something new to our customers today. So excited to be able to share that with you.
Great. And Ken, please.
Yes, good morning. It's a great pleasure to join this panel. Thanks to GSOA for having me. My name is Ken Takagi with Intelsat, and my role at Intelsat is the design and development of commercial solutions that build on Intelsat's next generation network. And our next generation network features key ingredients such as software-defined networking, 5G NTN, and multi-orbit networking. This is a major rejuvenation of our network from the ground up. And those key ingredients, along with a huge library of data that we have accumulated over the years through our services and through our satellite operations, gives us a very strong foundation for applying AI and machine learning. And we currently have multiple programs focused on applying AI and ML. And this includes a dedicated team in our innovation department. We've recently launched our first solutions leveraging AI to improve the customer interface to our service portal. We're also looking at programs that focus on improving efficiencies, improving QoE for our customers, which hopefully I'll be able to introduce as we go through the panel today. Thank you.
Well, thank you all for those introductory comments. Yeah, let's get into the Q&A. So in my introduction, I kind of highlighted that some of the critics kind of have claim that Satcom have historically maybe been a bit cautious in adopting emerging technologies. So many of you have been many years in this industry. So first, with maybe whether you agree with that, and if you believe that has been the case, just want to kind of understand from your perspective what is kind of finally shifting the shift today. So why do you see a shift in the market today or in the industry today that this is more of a push to adopt these new technologies much earlier into our systems and networks and processes? So maybe Will, you want to go first on this one?
Yeah, I'd love to. Thanks, Nathan. Yeah, I think our industry is driven a lot by our customers, right? As the satellite industry, we have historically provided services to hard to reach places that need a high availability. You can imagine an energy customer where you need that very high availability. So we're averse to making changes that could materially affect our customers. So every time we get new modem stacks and things like that, there's usually bugs. You have to work through the kinks of it, and I think that really kind of challenges our customers in a way that makes them adverse to change. Those industries themselves tend to be adverse to change in some of those things. But what we're seeing is the maturation of a lot of these base technologies over the years that have really helped us enable this journey. So not just in the satellites, Intelsat puts up EPICs, Starlink puts up LEOs. We're getting more and more capacity to these insights, which means we're able to start pulling more and more data from them. For those who are old enough to remember, the old days used to be serial. We were talking megabaud and kilobits, and now we're talking gigabits worth of data. So the sheer volume that's able to be pulled and used at these sites is really, really very useful. You have much less of just an independent site with critical data going back across, and you're starting to bring them into the fold even more. So that's probably one of the first enabling steps that's helped us to grow along this journey. I think the second one is probably SD-WAN. Right, this is something that's been out for many years. We've seen the technology mature. I think, just for example's sake, we were using Telaris more than 10 years ago to be able to bring multiple links together and help go through this. And they've since moved on and the technology's progressed, but it's helped to seed the industry to help us in this migration. So as we start to bring these more mature technologies into place, you can start to see that growth. I think Starlink was kind of the next really big step for two reasons. One, they work amazingly. Like, I don't know if you've all had a chance to use a Starlink terminal, but it connects quickly. It goes into blockage. It will find another solution. Your downtime is really low. I think they even published their SLA at 99.9%. It was a dream for us in the old satellite world to be able to get that far down the road and have such a robust solution as we go through it. So each of these is a major step. So as we look at how we take those steps, I think that's what's helping us with those shifts. These technologies are progressing, the industry is progressing, our customers are getting used to these solutions, and the solutions are constantly getting better. So we really have this great maturation of the pipeline to be able to get to where we are today, and you can see these steps. And we'll talk about some of the examples as we go through these questions. I don't want to get too far ahead here, Nathan, but it's something that really excites me as we go through it. Sorry.
No, that's very good. That's very good, and definitely we'll talk a bit more in detail about some of the points you mentioned. But maybe Ken, from a perspective of the satellite operator, what is your view on this kind of this shift in mindset from today, or anything you want to kind of add to or Will highlighted?
Yeah, sure. So I think sort of the legacy model was based on hardware. It was based on proprietary technology. Major technology upgrades were difficult and complicated, right? But the business model itself was working. That's why the satellite industry has been what it has been. What we have now is what I might call it the makings of a perfect storm, right? There's a number of market dynamics at play here. First of all, everyone's gotten so dependent on the internet. We have to be connected anywhere, everywhere we go, in whatever situation we are. And so there's a much higher demand for ubiquitous connectivity. And the best way to deliver that is via end-to-end solutions, right? And secondly, we have new tools now, software-defined networking, and a new set of standards, particularly the 5G NTN standards that really allow us it makes it worth our while to rejuvenate, upgrade our network, as I mentioned earlier. And of course, as Will just mentioned, we have disruptive competition in the form of the new LEO constellations, especially Starlink. So, I think the time is right, and I think everyone in the industry recognizes this, and I think we see a lot of momentum towards developing or applying these new capabilities using the new tools that also in turn give us a foundation for applying AI and ML.
Good. And yeah, definitely, I think, we all kind of highlight so far that the kind of time is now, and Sridhar absolutely, SC Engineering, have been putting a lot of effort as well in kind of driving this AI ML wave in SATCOM. So can you talk a little bit about that a little bit, and maybe as well, why the call for action is now, why we need the wait and see approach, if no worry applies here?
Yeah, absolutely. I think as the team pointed out, the technology is here. I think it has demonstrated that it's pretty mature and reliable now. So the technology landscape is definitely allowing us to think more strategically on incorporating these new technologies more aggressively. The market dynamics have dramatically changed with new entrants, and the market is being challenged, right? So as it was pointed out, Starlink and Kuiper is coming into the market, and they come from a completely different background than what SATCOM is traditionally used to. And that's challenging the market. And it's up to all of us, the vendors providing ground infrastructure, the space vendors, the operators. It's time for us to step up our game and meet the challenge, right? And I think we have tremendous amount of opportunity. We have the right networks. We have lots of data. But it was very hard to accumulate this data with the old hardware and technology that we were using. So we really could not put that to good use, right? So, but now with the advancements in technology moving, the evolution towards virtualization and cloud native architecture is going to enable us to start doing more things that we could not do before with bespoke hardware and bespoke solution. So definitely evolution towards cloud native architecture, and having the standardization is going to be driving more interoperability between these networks, and we have access to a lot more data than what we used to have before. And the technology landscape, like the big data technologies that are out there, and Microsoft offers a lot of technologies to store the data, process the data much more faster than what we used to before. So that enables us to open up lots of new applications, right? Again, we have a rich set of data that we collect from our terminals, our hubs, and the space infrastructure. If you can really put them to use, we can solve problems more aggressively. It takes a lot of time today to operate these networks and troubleshoot these problems. So by leveraging the data and leveraging AI, we can drive towards more operational efficiencies. We can move towards more intelligent, predictive, actionable intelligence. And start driving more improved security, because as you move towards standards and open architecture, security becomes even more important in this landscape, the geopolitical landscape that we are in. So the technology is there to support that as well. And ultimately, as the title of this webinar is, we have to drive towards a closed loop automation, towards autonomous networks. There is a good opportunity for us to improve the utilization of the network, because a lot of the data used to be manually processed, and if you look at the 999 is what we are trying to accomplish for SATCOM. Telco is at 5 nines. But also, if you look at the capacity utilization, I think there is a lot more opportunity to get more out of the network capacity that we get out of from a bandwidth perspective. So the technologies is here. We have the data. I think by leveraging AI and ML, we believe strongly that we can drive more automation into these networks, and most importantly, collaborate with the ecosystem partners, whether it is the operators or the vendors and partners, to put together a more comprehensive solution for this industry. So Telco went through this journey about 5 to 10 years ago. So they were also a little bit slow to adopt AI ML, right? But then the telco industry has adopted it, and they have reaped the benefits of it. And SATCOM industry traditionally follows the telco industry. So I think there's a great opportunity for the SATCOM industry to reap the same benefits that the telco is now beginning to reap.
Good, good, good. And Ming, maybe obviously, undeniably, Microsoft has been at the forefront of AI. So how do you see that kind of AI enabling higher satellite communication or observation networks, or kind of empowering the satellite industry? Maybe some views on
Yeah.
that.
Yeah, thank you, Nathan. So, we sort of see it in a couple different ways. Sridhar mentioned that the technology is here and it's becoming mature enough to utilize on operational systems, and that's true. And so, with Azure AI's suite of AI services, we can help organizations and companies produce these and develop these systems right now. But in terms of leading the wave, where Microsoft would like to, or where we see ourselves is positioned to help pathfind on behalf of our customers and pathfind on behalf of the organizations that our customers represent and the users that they represent. And so we do that in a couple different ways. One, the ETT was stood up to sort of marry up the technology to the domain space, right? And so what we do is show customers such as NASA, as an example, how we build multi-agent systems, how we build systems that we use internally to these 165 plus thousand employees of Microsoft, how we adopt these technologies and the lessons learned that we can provide to NASA. Very specifically, as an example, NASA was very big on trust. And trust in AI is, to my mind, right now, one of the biggest hurdles that most organizations are struggling with, right? AI in general is non-deterministic, it's stochastic in nature. So how do we trust this technology to make decisions on our behalf, given the stakes that we have, right? So those are the kinds of experiences that we can bring to bear on behalf of, for our customers and for the organizations that they represent. And then the second sort of area that we are leading the way is with organizations within Microsoft, such as Microsoft Research, right, itself. And specifically, MSR, Microsoft Research, is working on things such as small language models, right? So our Phi series of large language models are built to run not on supercomputers, not on huge GPUs, but potentially on in containers, right? In on-prem, in small form factor kinds of places, including on orbit. So as we start to move to an era where we push much of the reasoning to the edge in order to get insights much quicker, right? From the Earth observation perspective, what we would like to do is see data filtration, if you will, right? On, hey, look, is this a real thing that we're seeing here, or that's worth processing on the ground, or not? From a SATCOM perspective, we can see the application of small language models and reasoning at the edge to detect anomalies on orbit prior to it becoming an issue, right? So that's one area MSR is looking at. Another one, and where we see a lot of potential use here, is in true multimodal models. And so when we talk about multimodal models in the LLM world, we typically talk about text and images and video and speech, right? As an example. But multimodal also can mean, say, in the medical field, X-rays and MRIs and blood tests, right, for a particular health event. In the world of Earth observation, which is where I come from, it can mean an optical image. It can mean a radar image. It can mean signals emission, right, from a particular object or a target of interest. And so, in robotics, it can mean sensor input from a conveyor belt, from vision inputs, from temperature sensors, et cetera, right? And so that's where we're beginning to lead the way, and that's where a lot of our research is focused in the multimodal arena. And then the last one I'll talk about here, and then see the rest of my time is so we talk a lot about large language models. What we're beginning to see is the rise of what we call large action models. So large language models are typically that they're triggered, I'll say, by a user's input to ask a question or make some kind of a request to the model. But in the world of SATCOM, in the world of Earth observation satellites, what we're beginning to see is that we can put large action models that instead of being triggered by a request, a text, it can be triggered by other sorts of input, potentially multimodal inputs, potentially sensor input, and then make autonomous decisions, right? As Sridhar kind of mentioned before, about what to do. And those are the kind of models that we feel are going to be most applicable to the SATCOM industry here.
Great, and yeah, I like that you already highlighted some kind of practical examples. I think that always helps a lot for our audience as well, and myself included. So I would kind of ask each one of you to maybe provide one or two kind of real life examples on how you've applied AI ML and what kind of benefits had it delivered. What you think has been the most impactful for your organization or for your customers in the satellite network environment. So maybe I can ask Ken, you want to go first, and then I give, keep it short, but just
Yeah.
kind of a clear example, kind of how it impacts would be tremendous helpful.
Yeah, sure. So we are looking to apply AI in stages. So I mentioned earlier, we've already launched our initial AI-based solution, which is an interface to our customer portal, SMP. This builds on work that has been ongoing for a number of years to integrate the different products and the technologies that those products run on into a single user interface. We'd already done that. Now we're using AI to smooth the user interface to help improve the user experience in accessing this customer portal. We have a solution that allows our customers to talk to the system or chat with the system. They can do this in 80 languages, and they can provision new services, activate terminals, check the status of their network. And this is all driven by AI. That was our initial step. Now we have programs looking at network optimization, particularly in mobility areas like aviation, where the relationship between the satellite and the terminal is dynamic and constantly, getting updated, right? We're using AI to predict, or we're looking to use AI to predict network congestion, for example, so that we can prevent the congestion situation from happening and load balance capacity in advance. That will help improve the efficiency of our network. It obviously improves the quality of experience for end users as well. And then one step further in the future, with the arrival of our software-defined satellites, these are satellites that are designed to be extraordinarily flexible. In order to take full advantage of that flexibility, we are developing software of our own that will manage the interactivity between the terminals, the hubs, and the satellite itself, so that we can track demand and optimize the network, be it in terms of the satellite beams and the capacity allocation, or in terms of the optimizing the links in a dynamic manner. Okay. And this is an opportunity for us to apply AI. If we just leave it to software, then there's going to be a lot of processing, and the adaptation of the network may take that much more time. Whereas with AI, again, we get to apply capabilities like prediction in advance, so that we can predict when a network adjustment is going to be required, and the software starts working in advance, so that the adaptation of the network becomes that much more real time and dynamic.
Great. Yeah, maybe Will, you want to also highlight some real life use cases?
Yeah, absolutely. So I think it was probably 7 or 8 years ago, we started to switch over to predictive data, right? So as we have all of our data in our databases, the machine learning already starts to adapt to understand how that data changes in time, and then it'll start to predict what that data looks like out into the future. So that as you start to see variances against that, you can start to issue tickets ahead of time and start to track things that are going to break before they break, which is really great. Like, it is a fantastic addition years and years ago. So I think that was probably where our journey kind of started. And then, of course, I think like Ken said, where you're starting to use it for ticket and incident support, where you have a knowledge database that you can query, just like in ChatGPT. What happens if this goes on? It really makes troubleshooting tickets easier, You can also distill through your data a bit faster. So it was really a good way to apply it in your support process and being able to modernize the support infrastructure. But these days, we're moving well past that, right? We're getting the databases in places. We're using low code implementation to start to capture more data across multiple sources. And you're using disparate data to make decisions. So, the SD-WAN manages congestion and things like that for us. But at the same time, the SD-WAN may not be intelligent enough to really understand, when your LTE signal starts to drop, how much has the bandwidth in your tunnel changed, or what does your latency look like? Or it may look like a great link until you flood it with something, and then the link collapses because your RF signal strength is low and it can't tell the difference. So now you're starting to bring multiple pieces of data together. So how far away is that site? What's the cell signal strength? What does the weather look like? Is it a weather impacted where it's starting to rain, so your cell signal is about to drop? So I think like Mean said, you're starting to bring multimodal data into play already into making these decisions. Looking at geofencing, letting somebody know that they're about to sail into it. All of this is active in our network today, where you can bring this data to bear on making your decisions. So as we start to grow in our journey here, I would say that, we've been using ML for many, many years. We're using AI as we look to help, troubleshoot and resolve tickets. And now we're moving into even more complete databases, bringing multimodal data together to help make decisions on the edge around how these networks function and structure. And I'm really proud of what the team has done. Like Ken said, we have a team internally that's been coding and working on this for a long time to be able to bring that value add to our customers. Like I said at the onset, I think a lot of our industry is driven by our customers themselves, right? And what they look for: more data, more availability. Earth observation is different, right? I think Earth observation is, they want to process at the edge, so they're not backhauling a million photos every time. So you really have to kind of push that to the edge. As well as, even in security, when you look at cybersecurity, I think there's a question around cybersecurity. A lot of these cybersecurity firms and firewalls are moving to AI-based security algorithms as well, which we've obviously implemented, so that they're much more adaptable to a lot of the threats that we're seeing out in the environment today. So there's really a lot of applications in ML and AI in our day-to-day and what we do. And I think maybe even more than some realize, you buy a firewall, it's going to have AI these days at that point. So, I think how you take and put your own special flavor on some of these things is really kind of that value add to it at the end of the day.
Yeah, no, I love these examples. I think they're very useful. Maybe Sridhar, you have any additional ones that you think could be worth sharing with the audience?
Yeah, just a few points here. I think what Google search did to search. I think the AI chatbot and the interfaces that we have there is now a necessary thing for each of these products. I think people are not consuming the products with UIs anymore. I think they really are looking for a more interactive experience from a user interaction with the systems point of view. So AI chatbot is now table stakes in pretty much all the products that we built, and our customers demand that as part of our core product portfolio as well. I'll talk about a couple of use cases. So one of the challenges that we have, obviously, we talked about predictive maintenance and all those things, but when things go wrong, how soon can we heal, right? The self-healing application is one of the key use cases that we are looking at. How do you perform root cause analysis and automatically heal the network when things don't operate as they're supposed to? And obviously, we want to be proactive about this, but if things go wrong, then we should have the ability. We are looking at use cases where we can build the ability to self-heal as well. The other use case that is critical is digital twin application, right? So when we deploy these satellites with so much of capabilities, with the new software-defined satellites going up and with so much dynamism in terms of how these networks are going to operate and the complexities of multi-orbit and mobile terminals and so forth, it's very important for us to have an ecosystem where you can actually run through simulations of what could transpire in a real production network, right? In order to get to more reliable networks, it's important to have a good digital twin to run through the simulations, ensure that we understand how the network is going to react to certain situations, and be prepared with policies and solutions and configuration changes that you may need to apply, whether it be security or operation side, ahead of time, right? So digital twin will be another critical application that I believe will help this evolution to adopt more AI-based applications. So I would say AI chatbot is going to be absolutely necessary. Root cause analysis, self-healing kind of use cases, and digital twin will be some of my examples that we are working on actively.
Good. Great. Yeah, maybe Ming, if you had a few more as well to add, that would be great.
Sure, sure. I'll talk about one in particular. Again, from the Earth observation sort of world here, right? And in there, in addition to what you mentioned, which is absolutely true, which is that the amount of downlink coming from imaging satellites is just vast and just too much for us to process and exploit on the ground. The example that I'll give is a little bit further up the chain, more towards the I'll say the collection planning and collection scheduling kind of side of things. And in that realm, what our operators are seeing is just an overabundance of choice, right? I think it was Pixelytics put out a report that said that between 2015 and 2023, that the number of Earth observation satellites had quadrupled in size, in number. And then within that number, I think it was like 1,200 or something like that in 2023, the kinds of sensor phenomenologies, right, between optical, IR, electronic emissions, RF emissions, radar, et cetera, those have really ballooned up as well. And then within each one of those phenomenologies, there can be dozens, hundreds of ways to configure that sensor for how to collect a particular scene. And so what we're seeing is that operators are just overwhelmed with choice, and what it's doing a lot of things to lead to poor outcomes. But at the end of the day, and especially for our government ISR customers, it is leading to what they call perfection paralysis, where they're trying all of the different permutations in order to get the perfect collect, and it's too slow. Adversaries have moved at that point, and you can see sort of the commercial kind of applications of that as well, right? Your competitors are going to move much quicker than you can. Events are going to happen for a SATCOM network, and you have to be able to adjust bandwidth for that in real time. And so we're seeing the same kinds of things. And so what we've applied AI to then is what we call agentic collection and satellite orchestration, where all of a sudden now a user can enter in a single natural language query that says, hey, there's a ship here called the HMM Min, right? And I want to monitor it for the next couple of days here. And the multi-agent team will actually receive that, discern the intent, and then make use of all of the, as Will mentioned as well, the disparate data sets that it has access to, including, right, AIS information about where that ship is, tradecraft in terms of how to collect that ship, predictive movements of that ship in terms of where it might go based upon traditional shipping lanes, et cetera, et cetera. It'll go find that ship. It will predict where it's going to go as a set of waypoints, and then it will autonomously task 2 satellite constellations that we are partnered with, Umbra as a SAR collector and BlackSky as an EO collector, to go task and to go collect on that particular satellite, right? So all of that with a single prompt from the user, and it's not it hasn't overwhelmed the user with all of the kinds of choice there, but all of that choice is available to the system, right? So it's the machines that manage the complexity, right, allowing the user to focus on what's important, which is I need to go collect the HMM Min, right? And so we've tried this before with ways to simplify tasking, right? And what that did was it sort of dumbed it down, if you will. It sort of gave us a lowest common denominator. What we want to see is the best of both worlds, where the cognitive load on an operator can remain reasonable, but they have access to the entire power of the set of constellations at their disposal.
That's good. That's very interesting to kind of hear as well the other kind of examples, especially from an EO perspective, where maybe AI and ML have been already adopted for quite some years now as well. I also wanted to kind of quickly look at the audience questions. So again, reminder for everybody to submit your questions through the Q&A function. We have one from Cole. This one is actually for Ken. So Ken, the question here is, would this AI on the Intelsat network also be able to detect network issues and self-correct them, allowing the terminal to log in successfully to the network? So Ken, can you give it?
Yeah, sure. So that would be one of the aims, right? We obviously, the overall goal is around improving network efficiency as well as improving the user experience. And so it's kind of a broad question because you can have a lot of different types of issues on the network, right? But it's clearly an application for AI to interact with network management, other systems, right, that operate our platforms and our services, and extract data, learn from that data, right, and learn to understand, what data patterns, happen before problems occur, right, and or what problems are likely to occur that can be fixed quickly. So actually, one of the goals is to not allow that problem to happen in the first place, right? But also, if it does happen, that AI knows the answer or how to correct the problem. And one of the goals would be, to have it, an agent that has learned from the data and knows how to fix it as quickly as possible automatically.
Good. Good. Thanks for that. I think that's well understood. So maybe coming back to the next part of the kind of questionnaire Q&A part. I want to first go back to a few points that I think Ming mentioned as well around the challenges of deploying AI and ML. One, I think you kind of paraphrase it as perfection paralysis. The other, I think more generally as well, the criticality of good data, right, that inputs your model. So maybe Will, for you, like how critical is kind of this data quality into delivering kind of the successful applications of AI and ML, and kind of any lessons learned or anything you think that needs to be improved to really help to kind of improve the quality of the data?
Oh, absolutely. I think the old adage of garbage in, garbage out could not be more true, right? It also becomes really challenging when you're trying to marry multiple data sets together if you don't kind of have a uniform way to do it, right? Time, like Min was talking about the ship, right? If you're going to try to reconcile all these databases and you want to see the cloud cover over the ship, you got to look at the same time stamp on it. Your data isn't stamped. It's really hard to bring them all together. So in the AI ML world, it cannot be overstated how critical having your data accessible, accurate, understandable really is. Like we see a problem as just an example where to try to save space in databases, we'll see where a database will say, okay, the value in this database is 5, right? This is the information I'm recording. The value is 5, and it's 5 tomorrow, and it's 5 the next day, and it's 5 the day after. Oftentimes, we'll just see no entry, right, until it changes to 6 or something, right? So you'll see the edges where it changes, and then it'll kind of just blank out that data. And if you don't know how to process or how to interpret that data, you may pull a day that hasn't changed for an eon, and it'll say nothing. You got to realize you got to go back and look at the previous data to see what that one was. And it's all about how those databases save that data. So how you look in your databases, how you store that data, and how you reconcile it to something else is really an important step. So again, like it's that enabler in that journey. If you don't do it, how are you going to put a machine learning onto something that you can't tell the machine how to learn it? So it's got to start with your data.
Very good. Maybe Sridhar, maybe from your view, the point about data quality, how you can ensure, the strong data quality that you can generate, and maybe also looking forward a little bit, how do you see any kind of collaborative models in terms of, working with partnerships to kind of help accelerate, kind of either improve the data, but also just help accelerate the use cases?
Absolutely. I think, as Will rightly pointed out, everything starts with data and the quality of data, right? But the other angle to the data itself is the labeling of the data, which is a big deal because if you don't understand what the data actually means, that's going to be quite a challenge for the post-processing of that one and building the model. So I would say in addition to quality of data input itself, the labeling of the data is also very, very important here, right? Because that feeds into everything that we need to do from an AI point of view. In terms of other challenges that we need to face and also where collaboration can help is with a lot of simulation, there are a lot of models out there that we can use as a starting point in order to build our applications. But these models are trained on certain data sets. So you may have customer A who has a bunch of data and the model is trained there and certain behavior is accomplished. But I do believe that having federation here of these models being trained with data across various operators and various data sets is going to be extremely beneficial for the quality of the data itself, right? Because otherwise there's going to be an implicit bias that is developed into these models based on a certain data set and certain behavior. So exposing these models to more and more data sets across our install base is going to be helping our models to become more powerful and they can handle much more scenarios than what a single data set from a single network can offer. So we launched Automation Advisory Council precisely for that reason. This is to bring our customers, our partners, and all the vendors together to figure out how can we federate these models with more diversity of data in order to make these models more resilient and more scalable and more applicable for different scenarios. Because I'll give you one simple example. When you look at the rain fade scenarios and the weather patterns as one of the data sets, the weather pattern plays a significant role in satellite communication, right? And if you look at each geography, if you look at the effect of clouds and rain and the thunderstorms in certain regions has significant impact on how your network is going to operate. So having that intelligence and having the models trained on in each of these geographies helps the model strengthen further and understand the nuances of how the networks are going to operate when a terminal is in a specific region and when your beam is in a certain region. So that's a good example of just having data sets from various diverse entities in order to make our models much more stronger, right? So I definitely believe that labeling these data sets, having a more collaborative approach to have a federated model that can be trained on very different data sets is going to be helpful as we move forward.
Hey, Nathan,
Ming
can I
and you. Yeah,
jump
go
in?
ahead. Yeah, please,
Oh, I'm
yeah.
sorry. I didn't mean to step on you there, Nathan. So another aspect of kind of building on Shridar's point about labeling is one of the patterns that we're beginning to see, especially with generative AI that is exposed to either multiple systems or multiple users, is the labeling of data for purposes of access control, as well as the security of that data, right? So there are use cases where a user will ask a question of an agent team, and that user's accesses, right, whether it's a role or attributes of some kind, grant them access to a subset of all of the data that the model might know about. And so what we're beginning to see is are patterns that are emerging where the data has to be, and the data sources have to be labeled in some kind of a way that's coherent enough for the system to understand, oh, Min only has access to 4 of these 10 data sources. Will or Sridhar might have access to all of them. And so these systems are beginning to be built with that in mind. It's this, it's nothing new. It's old kind of thinking, but in a world where AI has by definition access to all of this stuff, how do we make sure that that data provenance, that data lineage, that data security is taken care of?
Good.
Oh,
Yeah,
and
no,
I'll make a quick I'm sorry.
Yeah.
I'm sorry. Just one quick plug for some of our services here. Like Microsoft Purview is the service that we have for doing a lot of that. You know, I won't go on and on about it here, but its job is to establish controls around your data estate such that you have positive control over everywhere that it's going. Thank you.
Good. Yeah, we have an audience question as well related to the topic, so I'm gonna share that with you here. The question is, are satellite operators willing to share the data with equipment vendors so they can improve their products? And how cooperation in this area happen without compromising the operator's privacy? So maybe Ken, you want to address that, and Sridhar, if you want to add to that, feel free to do
Sure.
so.
Okay, yeah, I mean, it's a good question. I think, you know, collaboration, you know, is a key topic. So if you think about like our next generation network, for example, we are virtualizing our network, right? That's separating the software from the hardware on the network. The ownership, you know, of different layers can be different. You know, multi-orbit networking inherently means multiple operators are involved. And 5G NTN, one of the goals is to enable terminals to roam between compliant 5G NTN networks, right? And this is all resulting in what I call the fragmentation of the different ingredients that make up a future service. You know, I think Will mentioned at the beginning, you know, Speedcast works with Intelsat, works with Microsoft, works with ST Engineering. And, you know, in the future, you're going to be working with more partners in the ecosystem to deliver one service to your customers. And so if you want to apply AI to that solution, you're going to need the ability to draw from the data sets of each of the, and the data sets are going to be owned by different owners, right? And you're going to, you know, come up with like a federated, you know, model, right? Based on the inputs from multiple users, right? So a collaboration is important in that environment across the ecosystem. And B, I mean, security is important, right? And I think, you know, again, this is where software AI should play a role, right? In ensuring that we retain sort of the integrity of our respective data, while at the same time, we don't want to, you know, limit the flexibility and, you know, the utility, right? The convenience that AI brings as well. So I don't have a specific answer that we've come up with yet, but it's something that as an industry we need to think about, maybe through standards or maybe through the collaboration between partners.
Yeah, I see. Maybe, I don't know, Will has his hand up, but maybe Sridhar, you want to go first and then
go to, okay. All right, so I think I could not agree with Ken more. As we move towards standardization, the data is going to be fragmented across multiple vendors and the data is going to be diversified. But 3GPP does have some solutions that they have implemented for the telco, so we can probably learn from that as to how we can collaborate to gather this data. And there are definitely technologies for anonymizing this, so we don't have to, I think there is a way to bypass or get around the privacy problem with this data. But most importantly, I think we don't need to bring all the data from the operators to a particular vendor, right? So I think we have the ability to take the models to the data. So I think from a technology point of view, moving data from place to place is not an efficient process. We need to take software to the data. So which means you can take a model, train it on data set one, and then take the model and deploy it in another network and train it on that data. So ultimately what gets improved is the model itself, but you don't necessarily need to bring the data back. So the federation could be at the level of the models, not to bring data from all the operators to one place, but it could be a combination thereof. Based on standardization, there could be some data sets that can be shared. In some cases, you can share the model, and there are technologies to overcome privacy issues through anonymization techniques as well. So I think there are opportunities for us to leverage all these technologies to continue to collaborate and build on top of it. Again, the industry can come together, and I'm pretty certain that we can come up with ways to address this. Telco has addressed this, and non-telco web applications have also addressed this in many ways. So we should be able to leverage those learnings and apply it here.
Will.
Yeah, from what we see, this is already available in many cases. It's really challenging, Sadir, to get a lot of these places to agree on data. It's not going to happen. The databases are set up and structured in their own ways, and that's fine. You've just got to learn how to work with them. So even at Speedcast, we have an API on our portal where customers can get the data for all of their sites in different ways through the API. So the proliferation of APIs is really what's driving a lot of it. So we pull APIs in from data sources, we reconcile that data, like I was talking about the 5 to 6, you've got to understand how to interpret it. And then you use that in your multimodal models because you're going to have to get data from multiple sources in a multimodal model. Wow, that's a tongue twister. So I think what we're really talking about is, are we going to see more people offering APIs for key data that's going to help them in somebody else's AI model? Yep, we absolutely are. And we see it today already, and it's already integrating into that industry. I think we just need to see more and more of it. And as those APIs mature, you're going to see more mature AI models and more mature databases, and it's going to continue to grow. But they are out there today, and we are using them.
Great. All right. So we have just a few minutes left. So maybe just to kind of end our discussion, maybe look at a more of a visionary, forward-looking question. So maybe we'll start with you, Ken. So maybe if you look at what we could maybe call as the holy grail of autonomous satellite networks, right? From your perspective, how does that look like? And realistically, how far are we from that to achieve it?
Okay, so for me, the topic that's close to my heart is around the 5G NTN and the ecosystem, right? That many of us in the industry are striving to achieve. The reason I bring this up is, the vision around 5G NTN is that SATCOMs becomes more like the mobile networks, where we can travel with our phones, and our phones work anywhere that we go by connecting to a local compliant 4G, 5G network that's available. And so the vision is that you'll have a universal terminal that has a single 3GPP identity, right? And you can take that terminal anywhere, and it will find a compliant 5G network, be it terrestrial or non-terrestrial, to connect to. Okay, and that vision is becoming real. A lot of the players in the industry are embracing that vision and adopting 5G in their solutions, in their services, and that's all great. But if you think about it, it's sort of, it's inferring to a lot of complexity down the road, right? The relationship between the network and the terminals is going to change. Today, 99% of our terminals connect to one network. Okay, whereas down the road, we're going to have terminals that will have multiple 5G NTN or TN networks to choose from. And each of those networks is going to behave in a different way, right? The LEO constellations are in different orbits. They have different inclination angles. There's different numbers of satellites, different beams. Okay, MEO, GEO all behave in different ways, right? And so to enable that kind of smooth roaming of terminals, between networks, and enable 5G NTN networking to be truly ubiquitous and something that end users can really use, right? We're going to need the help of AI, right? That goes beyond the 3GPP standards, that enables that vision to happen. Okay, and so this talks to the need for the standards themselves and people to adopt the standards, but also, like, as we move forward, I know there's already discussions at 3GPP around AI, and it's likely to be, there's likely to be a framework, perhaps in 6G, certainly release 20 and beyond at 3GPP. But I think there's going to need to be a collaboration across the industry to really, not just enable the terminal to talk to different networks, but to enable that user experience to be as smooth as possible.
Great. And maybe looking more like how AI and ML can transform the kind of customer experience, what the impact there could be on that front. So maybe briefly, Sridhar on SATCOM, and Ming maybe on EO. Could you give us your views there? Sridhar, go
Yeah, I
first.
think Sure. I think ultimately, as Ken pointed out, seamless mobility is the ultimate goal at the end of the day, right? So making sure that we can meet the customer expectations in terms of quality of experience, and being able to allow them to roam seamlessly and between terrestrial and non-terrestrial networks and provide connectivity um, across land, air, and sea, right? That's our nirvana goal at the end of the day. And also from an AI perspective and autonomous networks perspective, I think if the SATCOM network can evolve from mission in the loop to human in the loop model, right? I think that would be a great transformation for the SATCOM industry itself, right? I think we are going to get to a point of higher efficiency, more interoperability. We are going to be able to actually move from 3 nines that we have struggled to achieve so far, and maybe dream of getting to 5 nines, which telco has already accomplished. So with the 5G technology, I think there is an opportunity for us to head in that direction, hopefully, right, in the future. That also means that you can utilize the network even better. So right now, the utilization is not over. The oversubscription cannot be supported. We always tend to be conservative. We undersubscribe, and we may not be utilizing the capacity as much as we could have if we had the right technology in place. So which also means it opens up opportunities to expand our network in a more cost-effective way. So I think if we can accomplish those things, I would, I would think that will be our nirvana at this point of time where we are.
Very good, very good. Ming, maybe give the EO angle on this.
Yeah, so from the Earth observation side of the house here, you know, it's really the realization of something that we've been trying to do for 20 years, which is to move away from the human thinking about how and what, right, from a collection perspective, more towards the whys, right? So as an example, I gave this the ship example, but other ones, you know, include, you know, if from the operator, I'm sorry, from a user's perspective, you know, I want to monitor soil conditions or air quality or carbon cycles over a particular spot of land for the next year or something like that, right? Without having to understand any of the science behind how to go about doing that, not having to understand the fleet of Earth observation satellites that are there, right? But that you can move towards prediction things, right? So where you say, hey, I'm anticipating this kind of an event is going to happen in the next 7 days over here. Tell me when it's getting ready to happen, and have the system through its expert knowledge bases understand what that event looks like, right? And what the signs of that event might be, and then have it proactively go do something about that, whether it's an alert to the user or potentially autonomously taking action on its own. But then, you know, more towards the operator side of the house here, operators just want to be able to understand the state of the system, right? Without having to look at 50 different screens and 50 different sets of time series metrics and things like that to aggregate it together to say, I'm not polling anymore for how my system is working. Instead, the AI agents, right, can understand that, can understand what the patterns look like when a system is beginning to falter or it's getting into a degraded kind of a state, and then alert the operators instead, right? So that's where that's for me the holy grail, and where the vision is moving is again allowing humans to do what humans are really good at, which is high level reasoning.
Great. Good. Last question. Our time is almost up here. For you, Will, I will take an audience question for that. So let me share that with you. So, as AI-powered satellite networks increasingly rely on cross-provider integration, will competitive advantage stem from superior onboard intelligence or from the ability to orchestrate a more adaptive and interoperable ecosystem?
So it's an interesting question, right? Because I think it's talking about, you know, how are geo providers going to be able to, you know, differentiate one from the other? And, you know, I think I'm also going to tie it to kind of that closing question there. What's this mindset that we all need to be in?
Mm,
We are in, I like Ming's word, I'm going to keep using it, a multimodal satellite world these days, right? It's no more just GEO, right? GEO has some limitations. It's got some really great benefits, right? It's super steady, C-band, constant availability, really great positives to it. But Starlink is here. And Starlink is not going anywhere. They have a lot of great data. They have a really great service. OneWeb is providing service to customers. Amazon is launching satellites. Telesat will be online. LTE is doing better than it ever has. 5G LTE onshore-based solutions. And what we're seeing at customer side is all of these solutions coming together. So if a GEO satellite can orchestrate or software define better, what it really means and what it really translates to is it's going to be able to provide a better, more cost-effective service to compete with a LEO solution. Now, how they get their business model to better compete with LEO is up to the GEO operators at the end of the day. They need to work together better. And Ken knows this just as well as I do. Like as SES and Intelsat come together, you'll have the largest GEO fleet. Interoperability with all those satellites can go away at that point. And then it's more of like a GEO versus a LEO competition. I think that's part of that whole discussion point. So I don't know that it really creates an advantage for them as much as they're going to have to look at their service and their cost price point versus the other options that are available to customers in the market. When you look at orchestrating and adapting in that ecosystem, how you bring in this multimodal data, how you process it in AI to deliver the service to the customer is going to make the difference. That is the secret sauce for everyone. How do you pull and look at the databases? What are your algorithms doing? How are you assessing this versus that? How do you bring a better service to a customer for a better price? It's really pushed to that level at this point. And AI is your tool to help you do that as you bring and look at all of these different areas.
Perfect.
Just to-
Yeah, you want to very brief because we're definitely running
Very,
out.
very brief. I think I do believe that the ground infrastructure has a significant role to play here. So it's actually answer to this one is both. So you have the superior onboard processing intelligence that you put on the satellites, but having the right ground infrastructure that can harness the power of the onboard capabilities is extremely important as well. So innovations on the ground is as important as the space onboard processing.
Absolutely.
Nathan, if I can just weigh in quickly to Will's comment as well. And so one of the areas that we're looking at with AI that I mentioned earlier is leveraging GEO's ability to move large quantities of capacity to where it's needed in real time, right? And so this is going to be one of the benefits. It's not a benefit we had on our legacy satellites. It's something that's going to become available with our SDS satellites as they become available. And so we're looking at ways to apply AI to enable GEO to differentiate better and have a clear value proposition as we move forward, and to complement LEO MEO systems that are emerging into the industry scene.
Great. Thank you for that, Ken, and thank you all panelists for sharing insights today. I think it shows it's a fascinating topic and much more to come about that in the coming years for sure. So that brings us to the end of the discussions today. Any questions we didn't have time to answer during the live program will be addressed in writing and posted along the video on the GSO website. You can watch the recording as well, the webinar, as the previous one on the YouTube channel at GSOAsatellite.com. So GSOA webinar series will be on a break, well-deserved summer break, and we look forward to welcoming you again in September for the upcoming details on the upcoming events. Please visit the GSOA website, and they're all free for to watch for your convenience. Again, a big thank you for the panelists today. A big thank you for the sponsor ST Engineering for bringing us together, as well as GSOA for organizing that, and to an audience for your questions. I hope you all have something learned from us today. I'm very happy that so many of you joined today. I would wish you a great day ahead or a great evening, and hope to see you soon again. So thank you all.